Alright, for our topic today, we're going to be talking about multiplication properties of exponents. So, you should have explored in the lab and found out that a to the m times a to the n is really a to the m plus n. So the rule is that we're going to add those exponents together. I will explain to you logically why that is as we go through some examples in case you have not completed that lab. But as we look at this problem, what we really have here, and here's the logic behind it, we have 5 times 5 times 5, and then here we have 5 times 5 times 5 times 5 times 5 times 5, 6 times. So if I go ahead and place this time sign here between them, I now have it's really 5 to the 9th power. Now if we just learn that rule and we're able to keep that rule in our head or think about it logically, we can just directly go to our answer of 5 to the 9th. Because of how large 5 to the 9th really is, I am not going to multiply out 5 times 5 9 times. So I'm just going to leave my answer as 5 to the 9th. Most of the time I will go ahead and say what that answer is. So in the next problem here, these are the ones, I'm going to underline them in different colors that have the same base. So the rules, and I am going to start talking about the rules, is we keep the base and we add our exponents together. So we'll be adding 4 plus 2, which is 6, times, okay, we're going to keep our base, and we're going to add our exponents. Negative 3 plus 6 is 3. Again, because of how large the numbers are, I'm going to just go ahead and leave my answer like this for right now. Please never, ever, ever tell me that this is 21 to the 9th power. You cannot do that because they do not have the same base. The only thing we could do if we wanted the actual number is to actually put in our calculators, either using the exponent part of our calculators or typing them in by hand. 6 3s multiplied together and then 3 7s multiplied together, and we get a rather large number. On this next problem, let's go ahead and use the rules again. Keep the base, add the exponents. Negative 3 plus 3 is 0. We know that anything to the 0 power is 1. The next problem, I have Q's and I have R's. My Q's, I keep my base, I add my exponents. 3 plus 6 is 9. And then my R's, I'd have R, I'd have 2 plus what's here? Well, there is a 1 there, so 2 plus 1 is 3. So my answer would be Q to the 9th, R to the 3rd. The next rule we want to talk about is the A to the M to the Nth. So we have a power to a power. We are going to keep the base and we're going to multiply the exponents together. I want to explain to you at least one problem of that logically. So what this really says is I have 5 squared 4 times. So if I write that out, 5 squared times 5 squared times 5 squared times 5 squared, this is what I have. But now if I even take that further, I have 5 times 5, because that's what 5 squared is, times 5 times 5, because that's what 5 squared is, times 5 times 5, because that's what 5 squared is, and then 5 times 5. So I end up with 1, 2, 3, 4, 5, 6, 7, 8 5s. Using that rule of power to a power and just multiplying those together, I could just multiply 2 times 4 and get my answer of 8. So we're going to use that rule from here on out. We're going to say this is 4 to the 3 times 0. 3 times 0 is 0, and I know 4 to the 0 power then is 1. This next one we really need to be careful on because we've got 2 rules being used. We do need to take care of the power part first, the exponent to an exponent part first because of rules of order of operations. So I really have x to the 4th times, I need to take care of this part first, so 3 times negative 5 is x to the negative 15. Now we have the same base, we're going to add our exponents together, and so I get x to the negative 11. This one, we're not going to leave our answer in that form because it's not happy, so I highlighted it, and I need to make it happy, and I'm going to move it to the bottom of the fraction. So my answer ends up being 1 over x to the 11th.